Hello John and welcome to our science lesson today. Today we're going to be focusing on solids and liquids and what happens when we apply different hot and cold energies to them. So to start off, I would like you to tell me what a solid is.
Something that's like dense.
Something that's dense, wonderful. So here I have an example of a solid. This is a nut. What can you tell me when I put it in my hand?
Just stays the same.
It just stays the same. What happens when I put it in a container like that?
Just stays the same.
It just stays the same. So it's retaining its shape, it's retaining its mass, and it's retaining its volume. So good job. What about a liquid? What can you tell me about a liquid?
It won't keep its shape.
Exactly. If I put that in my hand, it would just go everywhere, wouldn't it? Wonderful. So here I have 250 milliliters worth of water. So that's its volume. Then I'm going to pour it into a container here. What do you think is going to happen?
It'll just go everywhere. Take the shape of the container.
Take the shape of the container. Wonderful. So its mass and volume has stayed the same, but its shape has changed, hasn't it? Good job. Well done, John. Alrighty, so in front of you I have a few different cutouts. Would you mind saying them out loud and putting them on either side? Which one you think they are?
Yep. Water. That's a liquid.
Wonderful. We just went through that one, didn't we?
Yep. The toilet paper. It's solid. Strawberry. Solid. Milkshake. That'd be a liquid.
Wonderful. See how it's already conforming to the shape of the container, the glass. Good job.
A pen. Be a solid.
Well done.
Rocks.
That'd definitely be a solid, wouldn't it?
Ink. And a fork.
It's a solid too, isn't it?
Yep.
Well done, John. You did very good. Now, do you happen to know what the science is between a solid and a liquid, like the actual science behind it?
Mm-hmm.
So, liquids and solids are actually part of what we call a state of matter. Now, there are actually 4 states of matter: solids, liquids, gases, and plasma. But we're only going to focus on solids and liquids. So, each state of matter is actually made up of different compressed molecules. So, molecules are what everything is made of. Here I actually have an example of a water molecule. These are different atoms built together to make a molecule. So, over here, I've got 2 different examples of different molecules. Now, one is a solid and one is a liquid. Which one do you think is which?
That'd be the solid one, actually. And that'd be the liquid one.
That's the liquid over here, so this would be the
solid one.
Wonderful. Why do you think that is?
These are more compressed.
And these are?
More scattered and separated.
Wonderful. So, because they're so tightly compressed, they can't really move, can they? There's no space for them to change their shape. So when we put our solid shape in a different container, it doesn't make any difference, does it? Whereas our liquids, all the molecules are spread out, which makes them change their shape, but they still have the same mass and the same volume. Good job. Now, when we combine different solids and liquids, we often form physical and chemical reactions. So, just an example, I've got some water here and some sugar. What do you think is going to happen when we combine the two?
It'll just dissolve.
What will dissolve?
The sugar.
The sugar will dissolve?
The water.
Alright, so shall we test that one? What can you see that's happening?
It didn't dissolve?
No, it didn't dissolve, did it? It looks like a few have dissolved. Cynthia, can you see up there?
Yeah.
Wonderful, but they actually haven't dissolved at all. The water has separated the sugar molecules into thinner pieces and kind of grabbed the outside of the sugar molecules, but the sugar's still there. It hasn't dissolved at all. It's simply made a mixture. So that's what's really happened. Our sugar molecule and our water molecule have just combined to make a mixture. Well done. So now we're going to begin our inquiry. We're going to look at what hot energy and cold energy does to different solids and liquids. Can you think of anything that when I apply heat to, it changes its state of matter?
Bread. When you make bread.
Bread, yes. So our mixture is adding a heat element to make it rise. Wonderful. And what about cool elements?
Cool. What, the ice cream?
Bang on, well done. So when we add our cream to our refrigerator, our freezer, sorry, it actually it makes it a solid, doesn't it? It goes from a liquid to a solid. Now, do you think to make ice cream, if I put it in the fridge, that it would have the same consistency as it would if it was the freezer?
No, probably not.
Why?
It's less cool in the fridge.
Exactly, so it needs a really cool energy to be able to form its really solid shape, doesn't it?
Yeah.
That's actually apparent with a lot of things. So here I have a chocolate bar. Now, if I were to put this in the fridge, what would happen?
It just stays the same.
It would stay the same. If I put it in the car on a really hot day, what would happen?
It just melts.
Now, if I just put it outside in the shade, would it still melt?
Maybe a bit slower.
And in the car? Wonderful.
Yeah.
So, when we add different levels of heat, our molecules separate at different rates, don't they?
Yeah.
So, we're going to put our different chocolate bars in a couple of different places around to see what heat energy separates our molecules. So it'll actually go from a solid to a liquid, but at different stages. Let's do our inquiry.